It's your boy, Joseph Lane, Mr. Lane, Joe Sensei, Matua Joe, J Money, that guy. He's back at you again. This is 1.4 derived grades from 2024. I'm going through all the answers. This is question 1E. If you'd like to watch the other ones, you can. If you don't want to, don't do it. Right, we're going over this question. This one's kind of fun, I think. This is mathy math. This is mathy math. Right. Prove. That's a big word. Prove that the difference between the squares of any two consecutive integers is equal to the sum of these integers. Now, first off, if English is your second language, I'm real sorry, dude. Like, straight up, this one was a tough one. I would not want to do. They call math the international language, but really, we're interpreting math through English. And if you gave this to me in Japanese, I would be heartbroken. But let's look at some of the definitions of this. Integers. What are integers? Integers are whole numbers, right? So we've got 1, 2, 3, 4. Can you tell me what comes next? That's right. 5, 6, all the way on for infinity, forever, amen. Yeah, so all the whole numbers. We're trying to find out two consecutive integers. So integers that come one after the other. 3 and 4 are examples of consecutive integers. 5 and 6. If I've got 17, the consecutive integer is, that's right, 18. Yeah, so we want consecutive integers. Two consecutive integers equal to the sum of these integers. What's the sum? Sum is adding. So 18 plus 19, that is the sum of two consecutive integers. Oops, I meant to get rid of it. 56 plus 57, that is the sum of two consecutive integers. And they're asking us about the difference between the squares. Difference is when we're doing subtraction. And squares, you would think that would be your teacher, but no, squares is when you've got something with a little 2 above it, yeah? Something times itself. 17 times 17 is an example of 17 squared, right? Gorgeous. Okay, so now that we've looked at everything here, all the definitions of these things, we want to prove that the difference between the squares of any two consecutive integers. We want to do this with algebra. Okay, first thing we want to do is come up with a variable to express any number. And I'm just going to come up with a wild one here. Joseph Lane is not like other girls, and he's going to choose X. That is right. If I wanted the next consecutive integer, how would I write that? Well, I want it to be 1 larger than X, so I'm going to choose X plus 1. So we've now got two numbers that are consecutive. And it doesn't matter where I start. This is always going to be true. If I think that I want to start with 5, well, 5 plus 1 is 6. So that works. What if I want to start with 48? Well, 48 plus 1 is 49. What if I want to start with 3,728? Well, that's right. The next one, plus 1, is going to be 3,729. So this format right here is going to work for all of our integers. Okay? So we're going to take our larger integer first. Okay? And we want to find the difference between the square of that and the original integer. So here I've got the difference. Yeah, we're looking for this word difference. So now I've found subtraction between the squares. Here I've squared both of these numbers. So that's right. And consecutive integers. Well, here we go. We've got consecutives that are going right there. So we have, if you do this, gotten U. That's achieved. That's all you had to do for achieved. There's another thing that you could do for achieved. You could set up the second part of this equal to the sum of these integers. If you got the sum of the integers, you could do the same thing. And that's actually a little bit easier. I've got my first integer, and then I'm going to add my second integer. This 1 looks kind of silly. I'm going to change that 1. Now I've got my second integer. If you did this, you got a u. If you did both of them together, you got an r. So already, I have only really just this, all of this faff was just explanation, right? I wrote 2 lines, 1, 2, and I got a merit. How glorious is that? Right. Let's prove it though. Let's get excellence by proving it. Okay. Is there anything we can do to the right side of this? Well, these brackets, we have to do everything that's inside the brackets first when we're following BEDMAS, but there's actually nothing that we can do in here. So we actually can get rid of those. And we can say that this is equal to 2x plus 1, right? Because these are like terms. If I have a Chuck Norris and I add another Chuck Norris to it, I have 2 Chuck Norri, okay? So those are like terms. The other side of the equation isn't so easy. We have to do some FOIL. And if you've been with me through this entire series, I applaud you. You are one of the best students in my class and or not in my classes. Yeah? But you'll know that this wee thing here can be expressed this way as well. Right? These are the same thing. If I have 5 squared, that's the same as 5 times 5. And if I have 23 squared, that is the same as 23 times 23. And if I have x squared, that is the same as, sorry, if I have x plus 1 squared, that is the same as x plus 1 times x plus 1. Yeah? So when I do my FOIL process on this little bit here, I get x squared plus 2x plus 1 minus x squared. Yeah, you can go through and check it here if you'd like, but that is what FOIL comes out to. And again, we are told in BEDMAS that we have to do everything in the brackets first. But there's nothing we can do. There's no like terms in here. This is different from this, is different from this. So there's nothing we can do, which means that we can just get rid of these brackets. We've done everything in there now. And now we do have like terms. This term here and this term here are the same. So we can see that x squared minus x squared is 0, which means, oops, 2x. Ah, that ended up being ugly. 2x plus 1. Ha! Here we have gotten to a point where the left-hand side looks exactly the same as the right-hand side. So we have proven this to be true. Just like if I told you that 3 is equal to 3, you would not be surprised. Or if I told you apples are the same thing as, that's right, apples. Yeah, this has proved that 2x plus 1 and 2x plus 1, I've started with 2 different things, and I've come to the same outcome on both sides, so I get my beautiful excellence. Well, thank you for sticking around with me. This was the end of question 1. Come back next time, where I am going to try and teach you while also not getting pizza-shaped crumbs all over my computer. Come back for the fun!